Hi everyone, in this next video, we're going to be looking at factoring by grouping and some other techniques. I've provided the answers for the Check Your Understanding for the last video, so you can check those and make sure that you understand how to factor out the greatest common factor. If you look back at the flow chart at the beginning of the lesson, we're going to look now at factoring polynomials with 4 terms. Okay, so we have a polynomial, it's got 4 terms. And how do we do that? We generally use a technique called grouping. So we're going to literally group the terms. Sometimes you have to rearrange the terms to group and look for the greatest common factor, but usually the problems are set up, or the problem just happens to end up where you can group the first 2 terms, and then the last 2 terms together. So we're going to group these first 2 terms together, and we're going to group the last 2 terms together. And what you do is you pull out a greatest common factor from each of the terms. So that's why it's important to understand greatest common factor. So if you look at the 2 terms here, they both have an x. We take out the lowest one. So my greatest common factor would be an x squared. And then I'm going to write my leftover. So my leftover, x cubed divided by x squared is just x. And 5x squared divided by x squared is just 5. Okay, and I'm going to move this down. Now we're going to pull out a greatest common factor from here. So we have 3 and 15, and as you know, 3 goes into 3 and 3 goes into 15. They don't both have an x, so all I can pull out of there is a 3. Okay, so I'm just carrying down this plus, and then 3 is my GCF. So here my GCF was x squared, here my GCF is 3. And then my leftovers are 3 divided by 3 gives me 1x, and 15 divided by 3 is 5. Okay, now if you look at both of these terms, so let me highlight them. I've got my yellow and my orange. Okay, if you look at both of those terms, we have an x plus 5 in common to both, right? So that's our greatest common factor of each term. So I'm going to pull out an x plus 5 and then write the leftovers in the other parenthesis. So if I pull out an x plus 5 out of here, I'm left with x squared. And if I pull an x plus 5 out of here, I'm left with a plus 3. So my final answer is x plus 5 times x squared plus 3. And you can check that by FOILing and determine if you get the product or your original problem back again. In the next problem, if you'll notice, there's some negatives. And in the first problem, I had all positives, right? So let's look what happens when we have some negatives in there. If I try and group the first 2 terms and then the last 2 terms together, in the first 2, if you'll notice, they both have a y, so I'm going to pull a y out of there. And then in the last 2 terms, they have a -5 and a -10. So you want to pull the negative out with the GCF. And 5 goes into itself and 5 goes into 10. So we're going to pull out a -5 out of there. Okay, so then remember what we're going to do is we're going to divide. So xy divided by y just gives me x. And 2y divided by y just gives me 2. And then I've got -5 divided by -5, which is, let me put -5 here. Here's my GCF. -5 divided by -5 is positive 1x, and -10 divided by -5 is 2. Okay, and if you notice, we get the same expression in each of these terms, okay, which is what should happen. If you don't get the same quantity in parentheses, something's wrong. And sometimes it's just a matter of pulling out a negative along with the GCF. So if you notice, both of these have an x plus 2. So I'm going to pull an x plus 2 out of there. And then the leftovers would just be y and -5. So they're going to go in the other parentheses. And then that's it. So it's just x plus 2 times y minus 5. You can practice these next two on your own, and you would get the following answers. Okay, now we're going to look at two special cases. We're going to look at factoring trinomials by a method called guess and check. And we're going to look at when the trinomial first has a coefficient for x squared of 1. So it's always going to be like a 1x squared or a 1y squared. Here you notice there's not a 1, but there's a reason for that. And then we're going to look at factoring trinomials when a is not 1. So when it's something other than 1. Okay, so we're going to use a method called guess and check. And what we want, so if you think back to that problem we started with, which was x squared plus 8x plus 15, how would we get x plus 3 times x plus 5? There's something special about the 3 and the 5 and the 8 and the 15. Okay, so think about how do 3 and 5 relate to 8 and also 15? So we want factors that will multiply to give us the last term, but add to give us the middle term. So if you think about it, 3 times 5 gives you 18, or gives you 15, and 3 plus 5 gives you 8. Okay, so typically we want two numbers that multiply to give us the last term, but add to give us the middle term. So if we go back to this problem, x squared minus 2x minus 35. I want two numbers, so generally I'll draw like an x. Okay, you want two numbers that multiply to give you negative 35, but add to give you a negative 2. So think about numbers that multiply to give you negative 35. Okay, when you add them, you want it to give you a negative 2. So I'm going to put in my signs, okay, and here's a trick you can use for the signs. It's the first sign you see, so in this case it's negative, and then multiply the signs together. Negative times a negative gives us a positive. So this tells me I need a negative number and a positive number, okay? When you multiply them together, it'll give you negative 35, and when you add them, it'll give you negative 2. So think of numbers that multiply to give you negative 35, but then it needs to add to give you negative 2. Okay, feel free to pause the video and try it on your own, and then you can unpause it when you're ready. So if you guessed negative 7 and positive 5, you are correct. Negative 7 times 5 gives you negative 35, and negative 7 plus 5 is negative 2. So now the rest is easy. You're going to make two sets of parentheses, and we're going to split up this x squared into x times x. And then I'm just going to throw my numbers in. I've got a negative 7 and a positive 5. Okay, to check this, you can FOIL, which remember means first, outer, inner, last. So if you multiply x times x, you do get x squared. And if you multiply x times 5, the outer terms, you get 5x. And then the inner terms, negative 7 times x is negative 7x. And then the last terms, negative 7 times 5 is negative 35. Okay, you can combine the two terms in the middle. They're like terms. 5x minus 7x is negative 2x. So you end up with the answer you started with, which is x squared minus 2x minus 35. So that's how you know that this is the answer. Okay, so this is factored completely. So all you need to do is FOIL or distribute to check your answers. Okay, let's try the next one, letter B. Okay, so I want two numbers that multiply to give me negative 28 and add to give me negative 3. And the sign trick is the first sign you see is a negative, and then multiply the signs together. Negative times negative is positive. So it's a negative and a positive number. they need to multiply to give you negative 28 and add to give you negative 3. Okay, so feel free to pause the video and try it on your own. Negative 7 times 4 gives you negative 28, and negative 7 plus 4 is negative 3. So here I'm just going to have y minus 7 times y plus 4, and you can FOIL it and check to make sure your answer is correct. In letter C, we have 2n squared minus 38n plus 80. If you notice, the coefficient of n squared, your squared term, is not 1. So if in looking at this, you can see that there's a greatest common factor that you can pull out of here. You always want to look for greatest common factors. Okay, and A and B didn't have any greatest common factors, but C does because 2 divides into each of these terms. So my greatest common factor here is 2. Okay, what's left over? 2n squared divided by 2 is just n squared. Negative 38n divided by 2 is negative 19n. And 80 divided by 2 is 40. Okay, now you want two numbers that will multiply to give you 40, but add to give you negative 19. Okay, and you can pause the video and try to think of it on your own. So if you're having trouble thinking of numbers that multiply to give you 40 and add to give you negative 19, you're not alone. There aren't any. So your final answer is just going to be 2 times n squared minus 19n plus 40. So you would leave your answer like that. Not every trinomial can be factored further, and this cannot be because you can't find two numbers that multiply to give you 40 that add to give you a negative 19. Okay, and I'm going to end the video there. You can try the check your understanding below and make sure you're good with this type of factoring, as it's very common and important to know how to factor those. And then I'll see you in the next video.